everyone, grade 3. This is our 12th class of math. We're still in unit 2 fraction. Okay, the objective we need to reach by the end of our class, student will be able to compare visually between different fractions. Visually means you are going to use your eyes to compare between the fraction to tell me which fraction is greater than the other one, and students will be able to decide on which fractions are equivalent. Okay, equivalent, it's coming from the word equal, so equivalent fractions means equal fractions. Let's revise how to write a fraction. We know that our fraction is made of 3 parts. The first part, the denominator, down, d, down denominator, it tells us the total number of the equal parts, all the parts you have. And you have the fraction bar, and up we are writing the numerator or the number of some parts. If we are talking about the colored parts, so up will represent the number of the colored parts out of all the total parts you have. Okay, let's see here. Don't forget that if you colored the whole shape, it means you finished 1 out of 1. It means you finished all the one whole. If you cut your shape in 2 equal parts and you colored only 1 part out of the 2 parts, it means you colored half, 1 out of 2. If you cut your shape in 3 equal parts and you colored only 1 part, it means you colored 1 out of 3 or 1/3. If you colored 1 part out of 4 equal parts, it means you colored 1/4 or 1 out of 4. Now look here, you colored 2 parts out of the 3. It means you colored 2/3 or 2 out of 3. Now look to this shape. It is divided into 5 equal parts. So look to your denominator, it is 5. It means all the parts. Look to the numerator, it is 2. It means you colored only 2 parts out of the 5. 2 out of 5 or 2/5 is colored in green. Now take a look to the next shape. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. The total number of parts is 8. So we put it down in the denominator. And you colored 5 parts out of this 8 parts. So you colored 5 out of 8 in green. Let's move on. Okay, now I want you to look carefully to 3 rectangles. They are the same rectangle, but every time we cut it in a different way. The first rectangle, we cut it into how many parts? Only 2 parts. The same rectangle here, I cut it into how many parts? 4 parts. The third rectangle, I cut it into 1, 2, 3, 4, and 1, 2, 3, 4. Okay, 16 parts. And take care, all the parts in each shape are equal parts. So can you write a fraction for this? Yes, the green area is 1 out of the 2. Can you write a fraction for this area? Yes, it is 2 out of the 4. Can you write a fraction for this green area? Yes, it is 8 out of 16. But with your eyes, can you notice that the green area here, the same as the green area here, the same as the green area here? Yes. In this case, we can say that each rectangle shows the same colored area, but with different fraction. The first one is 1 out of 2. The second one, the same green area, but with a different fraction, 2 out of 4. The third one, the same green area as in the first shape and as in the second shape, but with a different fraction, 8 out of 16. So in this case, if you have different fraction representing the same area, it means those fractions are equivalent fractions or equal to each other. So different fractions showing the same green area or the same green part, they are equivalent fractions. Let's move to another example. Look to this bar. I cut it in 2 equal parts, so this part is 1 out of the 2 and this part is 1 out of the 2. So it means half and half. Then I take the same bar and in this time I cut it into 4 equal parts. And I can see this, that 1 out of 4 and 1 out of 4, these 2 parts only equal to this half. So 2 out of 4 equal to this half. Now let's see our third bar. The same bar, but I cut it into how many equal parts? Do you want to count or just look to the denominator? Yes, the denominator is showing 8. It means the total number of the parts are 8. But how many parts equal to this half? Take a look. 1, 2, 3, 4. So 4 out of 8 equal to this half, or 4 out of 8 equal to this 2 out of 4. In this case, I can say that this fraction equivalent to these 2 fractions equivalent to these 4 fractions. So let us see how to do it in a mathematical way. The 1/2 shows the same area of the 2 quarters, the 2 out of 4, which is the same area as shown by the 4/8, or 4 out of 8. So half equal to 2 out of 4 equal to 4 out of 8, because they are equivalent. So let us read this rule together. The same area shaded in each shape, so the different fractions are equivalent. Let us see more examples. Can you see this rectangle? I colored 1 out of the 5 parts in dark blue. Let us see. Here, this rectangle. As you can see with your eyes, the same rectangle, but I cut it in a different way. Here, I cut it into 10 equal parts. And if I want to color the same column, here I color 2 out of the 10 in dark blue. Here, the same rectangle, and I want to color the same area in a dark blue. So now, in this shape, I need to color 3 out of 15 to make it dark blue. Let's take a look here. Can you tell me what is the fraction of the dark blue? And you can see that it is the same shape, but I cut it into 20 equal, 20? Yes, 20 equal parts. So if I want to color only this column in dark blue, it means I need to color 4 out of the whole 20 in dark blue. 1 out of 5, 2 out of 10, 3 out of 15, 4 out of 20. Different fraction? Yes, they are different fractions representing the same area. So in this case, we can call them equivalent fractions. Okay, now let's take a look to this example. Here, I cut my shape into equal 4 parts. And here, I cut the same shape, but into 8 equal parts. And here, I cut my shape into 12 equal parts. But as you can see, this area, the same as this area, the same as this area. But this area is only 1 part. But here, it is divided in 2 parts. And here, it is cut or divided into 3 parts. So, do you think that they will have the same fraction? No, because the fraction is telling you the number of the total parts. So here we colored in pink 1 out of 4, and here we colored 3 out of the total 12, and here we colored 2 out of equivalent fractions. So please open your book, page 22. Okay, here he is giving you colored ribbons, and here the whole bar. Now then he cut the whole part in 2 equal parts, half and half. Then he cut the whole bar into 3 equal parts, and here he cut the bar into 4 equal parts. Take care, he is taking the same bar, and every time he cut it in a different way. Here he cut it into 6 equal parts. Here in the green he cut the same bar into 8 equal parts, and the last bar has been cut into 10 equal parts. So let's go to the question number 1. Write down all the fractions you can see which are equivalent to the half or equal to half. Can you see the half area? Can you see? 1 out of 4 and 1 out of 4. They are equal to this half. Okay? Let's 1 out of 6, 1 out of 6, 1 out of 6. So they are 3 out of 6 equal to the half. Look how many green parts equal to the half. 1, 2, 3, 4. So 4 out of 8. So let us see the answers. So 2 out of 4 equivalent to half. 3 out of 6 also equivalent to the half. 4 out of 8 also equivalent. And 5 out of 10. 5 parts out of this 10 equal to the half. Write down anything you notice about this fraction. First of all, look to the 1 whole bar and look to the half, look to the third, look to the fourth, look to the 6th, look to the 8th, look to the 10th. Which is the biggest one? The whole one is greater than any fraction, because as we said before, the fraction means a small part out of the whole one. The half is greater than the third. The half, this is all the half, but this is only 1/3. So the half is greater than the third. And the third is greater than the fourth. Look to the 1 out of the 3 parts and 1 out of the 4 parts. Also, the fourth is greater than the 6th. The 1 out of the 4 parts equal than the 1 out of the 6 parts. So we can notice that when the denominator becomes bigger, it means I cut my shape into more equal parts, the fraction or the part becomes smaller. 1 out of 2 is bigger than the 1 out of 10.